All right, guys, so we're doing Algebra 2, solving for x with radical layers. Today was going to be the last day of solving for x with checking for extraneous solutions. Tomorrow is going to be a review day, and then we're going to have a test due Thursday at 11:59 p.m. Okay, so first things first. Solving for x, check for extraneous solutions. So the square root of 2x minus 1 plus 2 is equal to x. So with problems like this, I like to get everything that is not a radical on the other side and everything that is a radical on its own side. So sorry about that, I'm just uploading a video for another class. So I need to make sure that it doesn't go into screensaver mode. Anyway, so the first thing I'm going to do is I'm going to subtract 2 from both sides. So if I subtract 2 from both sides, well, that cancels out the 2 on the left side, but it moves it over to the right side. So now I've got the square root of 2x minus 1 is equal to x minus 2. Sorry about that. And now I want to undo the radical to free it. And now I'm going to square both sides. So squaring both sides will knock out the radical. But now I'm left with the right side being x minus 2 quantity squared. Okay, so now that I've got the square root of 2x minus 1 is equal to x minus 2 quantity squared. It's basically the same thing as, sorry about that. I'm trying to cancel out this part, and so I did. Leaving me with 2x minus 1 is equal to x minus 2 times x minus 2. So then I'm going to FOIL each individual piece out. X times x is x squared. X times negative 2 is negative 2x. Negative 2 times x is negative 2x. And negative 2 times negative 2 is positive 4. Then I'm going to combine the like terms, negative 2x and negative 2x, and get x squared minus 4x plus 4 is equal to 2x minus 1. Now, I've got x squared on the right side and the makings of a quadratic trinomial. And I want to get rid of anything that doesn't get the quadratic trinomial. Everything on the left side is going to get gone. So I'm going to subtract both sides of the equation by 2x. And I'm going to add 1 on both sides. So that cancels out. Now I've got 0 on the left side. Negative 4x minus 2x is negative 6x. 4 plus 1 is 5. Now comes the tricky part. I need to factor this quadratic trinomial, as in what two numbers multiply to positive 5 and add to negative 6. So it needs to be a positive positive or a negative negative to multiply to a positive number. Looking at the right side, it needs to be a negative negative combination. So let's start with the obvious. Negative 1, negative 5. Negative 1 times negative 5 is positive 5. Negative 1 plus negative 5. Hey, it worked on the first try, so success. 0 is equal to x minus 1 times x minus 5. Now I use the zero product principle to split this into two cases. So now x minus 1 equals 0, or x minus 5 equals 0. I'm going to add 1 on both sides. And on the left side, I get x equals positive 1, hopefully. And on the right side, x minus 5 equals 0. I'm going to add 5 on both sides and get x equals 5, hopefully. Now remember, we're going to do the second part, check for any bogus solutions. So let's take a look at plugging in x equals 1 to the equation, and hopefully we get a true statement. The square root of 2 times x minus 1 plus 2 is equal to x, where x is equal to 1. So I've got the square root of 2 times 1, which is 2. So 2 minus 1 is 1. So the square root of 1 plus 2 is equal to 1. The square root of 1 is 1 plus 2 is equal to 1. 1 plus 2 is 3, and the right side is 1. So I did everything right. I followed all the rules, and I got a false statement. So that tells me that x equals 1 is an extraneous solution. That's not true. That's false. Let me see if I can get x equals 5 to be a true statement. 2 times 5 is 10. So the square root of 10 minus 1 plus 2 is equal to 5. Square root of 10 minus 1, that is the square root of 9. The square root of 9 is 3. 3 plus 2 is 5. The left and the right agree, so the only one that works is x equals 5. Once again, x equals 1 is not a true solution, but x equals 5 is. Okay. All right, let me block this out. Sorry about that. So let's let's solve the next one. See if you can do this problem independently. The square root of 2x plus 13 is equal to x plus 7. Okay. So what I want to do is get rid of that radical. Since it's already isolated, what I'm going to do is square both sides. So the square root and the square cancel each other out, leaving me with 2x plus 13 is equal to x plus 7 quantity squared, or 2x plus 3 is equal to x plus 7 times x plus 7. Now I'm going to FOIL x times x is x squared, x times 7 is positive 7x, positive 7 times x is positive 7x, and positive 7 times positive 7 is 49. So I get 2x plus 13 is equal to x squared plus 7x plus 7x plus 49, or we combine the like terms in the middle and we get 2x plus 3 is equal to x squared plus 14x plus 49. Now, I want to get rid of anything that interferes with my quadratic trinomial. So my quadratic trinomial is on the right side, so I'm going to move everything from the left to the right. So I'm going to subtract 2x from both sides and subtract 13 from both sides. Cancel out 2x and negative 2x, cancel out positive 13 and negative 13, and I'm left with x squared plus 12x plus 36 is equal to 0. Now I got to make that table and figure out what two numbers multiply to positive 36 and add to positive 12. A equals 1, so I don't have to do that split the middle term and factor by rectangle method. Okay, so if two numbers multiply to a positive, it can be positive positive or negative negative. But since it adds to a positive, it has to be a positive positive combination. So let's get right to it. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. So these are the positive combinations. Nope, 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 yes. So therefore, this becomes 0 equals x plus 6 times x plus 6. Or if you really want to be fancy, we know that there's only one solution, so this is x plus 6 quantity squared. So we break this down into only one case. So specifically, we set x plus 6 equal to 0. Subtract 6 from both sides, and the only solution, hopefully, is x equals negative 6. Okay, find the solution set. Well, I'm going to plug in x equals negative 6 into the original problem and hope that I get a true statement. So the square root of 2 times negative 6, that's negative 12, plus 13. Negative 6 plus 7 is 1. Negative 12 plus 13 is 1. So the square root of 1 is equal to 1. That looks good to me. So therefore, x equals negative 6 is the rightful solution to the problem. Okay. All right, moving on to problem number 3. Let me make sure I got my cover. So now, the square root of 2x plus 5 is equal to x minus 5. Sorry about the shaking, I just don't want to give away the answer. Well, how do I undo the layers to get the solution set? Well, I'm going to undo the layer by squaring both sides. Now, I've got x minus 5 quantity squared is equal to, well, 2x plus 5 because the square root and the square knock each other out. So this is x minus 5 times x minus 5 is equal to 2x plus 5. So that lets me FOIL both sides. X times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. So this becomes the FOILed out expanded form. I'm going to combine the like terms in the middle, negative 5x and negative 5x. That forms negative 10x. So x squared minus 10x plus 25 is equal to 2x plus 5. And now I've got a quadratic trinomial on the left side, and I don't like the right side, so I want the zero product principle. So now I'm going to subtract 2x from both sides and subtract 5 from both sides. Because subtracting 5 from both sides cancels out the positive 5. Subtracting 2x from both sides cancels out the positive 2x. And now I've got x squared minus 12x plus 20 is equal to 0. So now I got to make that table and figure out what two numbers multiply to positive 20 and add to negative 12. Looking at the left side, it could be positive positive or negative negative. But since they add to a negative, two negatives need to add together to get more negative. So let's make that table. Negative 1 and negative 20. Negative 1 plus negative 20 is negative 21, so that doesn't work. Let's try negative 2. Negative 2 times negative 10. Negative 2 times negative 10 is positive 20, but they add to negative 12. Ding, we win. So this factors into x minus 2 times x minus 10 is equal to 0. We use the zero product principle to split this into two cases, either x minus 10 equals 0 or x minus 2 equals 0. So let's solve both equations. All right, so now I'm going to add 10 on both sides and get x equals positive 10 I'm also going to get, I'm also going to add 2 on both sides and get x equals positive 2. So either x equals 2 or x equals 10, but hang on, we need to check if any of these solutions result in a bogus solution. So I'm going to check x equals 2 and x equals 10. So let's say I start with, let's go with 10 first. 10 minus 5 is 5. 2 times 10 is 20, plus 5, okay. 5 is equal to the square root of 25, and the square root of 25 is in fact 5, so all right, 10, you're good. X equals 10 is good. So let's try x equals 2. So if I plug in 2 minus 5, I get negative 3. Danger, danger, danger. 2 times 2 is 4. 4 plus 5 is 9. So even though you might think that this is correct, technically the square root only applies to positive unless there's a negative in front. So the positive square root of 9 is positive 3, and negative 3 does not in fact equal positive 3. So this is false. So x equals 10 is good, but x equals 2, sorry. So x equals 10 is the only solution in the solution set. Even though you did everything right and you followed all the rules, x equals 10 is the rightful heir to the throne. Okay, all right, let me get my cover. All right, blocking everything out of the way. Final problem of the day. X plus 8 is equal to the square root of 2x plus 19. Now then, see if you can do this problem independently. Pause the screen. Okay. All right, now, I'm going to scroll down. Sorry, I'm uploading a video at the same time. So now, how do I undo this? Well, same old, same old. I'm going to square both sides, and hopefully the radical goes away. So the squaring of the radical cancels out, but I'm left with x plus 8 quantity squared, or x plus 8 times x plus 8 is equal to 2x plus 9. So now let's FOIL the left side. X times x is x squared. X times 8 is positive 8x. 8 times x is positive 8x. And 8 times 8 is Nintendo 64. So I get x squared plus 8x plus 8x plus Nintendo 64 is equal to 2x plus 19. Combine the like terms in the middle, and I should get x squared plus 16x plus 64 is equal to 2x plus 19. Okay? Now then, I'm going to undo anything that doesn't contribute to my quadratic trinomial. So I've got an x squared on the left side, so I might as well make everything on the right side go to the left. So what I'm going to do is I'm going to subtract 2x from both sides. And I'm going to subtract 19 from both sides. Cancel out the 2x and cancel out the 19. 16x minus 2x is positive 14x. And 64 minus 19 is positive 45. So I'm left with x squared plus 14x plus 45 is equal to 0. Now, I got to figure out the winning combination of two numbers that multiply to positive 45 and add to 14. What two numbers multiply to 45 and add to 14? Well, first things first, what type of combination do we have? Positive, positive, or negative, negative? Well, positive, positive. So we make that table, and let's see if we win. 1 and 45. 1 plus 45 is 46. It's an odd number, so 2 can't go in there without being decimals. 3 times 15. 3 times 15 is 45. 3 plus 15 is 18. 45 divided by 4 is also a decimal, but 45 divided by 5 is 9. 5 times 9 is 45, but 5 plus 9 is, we win, 14. So this factors into x plus 5 times x plus 9 is equal to 0. We like this. We love a multiplication problem where the answer is 0 because it makes us use the zero product principle. The zero product principle states that if I have x plus 5 times x plus 9 equals 0, I can break this up into two cases. Either x plus 5 equals 0 or x plus 9 equals 0. So let's solve both of them simultaneously. If I were to subtract 9 from both sides, x is equal to negative 9. Hopefully that works. If I were to subtract 5 from both sides, let me just get the glare out of the way. There we go. Sorry, kitchen light. So I'm subtracting 5 from both sides, and I'm left with x equals negative 5. So either x equals negative 5 or negative 9, but I'm going to check my work to see if I did everything correctly and it's not a bogus solution. So let's plug in negative 5 for the first part of the equation. So if I plug in x equals negative 5 plus 8 is 3. 2 times negative 2 times negative 5 is negative 10, but I'm adding 19 inside of the radical. So 3 is equal to the square root of negative 10 plus 19. That's square root of 9. And the square root of 9, remember, it's the positive square root, so the square root of 9 is positive 3. All right, negative 5, you're good. X equals negative 5 is part of the solution set. All right, but let's plug in x equals negative 9. All right, so negative 9 plus 8 is negative 1. Now I've got 2 times negative 9 is negative 18 plus 19. So now I've got negative 18 plus 19, we've got the square root of 1. Remember, we're counting only the positive square root. The square root of 1 is technically positive 1. Negative 1 does not, in fact, equal positive 1. So x equals negative 9 is a bogus solution. So x equals negative 5 is the only solution. Okay? Tomorrow we're going to have a review day where we review how to solve with radical equations, how to solve with rational exponents, and we'll do maybe like 1 or 2 problems of this. Okay? Have a great day.